The next type of linear accelerators includes collective accelerators. Originally, the idea of collective acceleration methods was proposed at the same time by several scientists. Soviet scientists who are famous for suggesting these methods were Vladimir Veksler, Gers Putker at the Novosibirsk Institute, and Yakov Faunberg in Kharkov. So what was the idea behind it? And why did the desire to use other means of particle acceleration suddenly arise when, at the time, all main contemporary accelerators had already been discovered? Unfortunately, in all other types of accelerators, the electric field strength used for particle acceleration is limited by the high-frequency breakdown of the high-frequency cavity. The maximum electric field strength that had thus far been achieved on metal surfaces is between 100 and 200 megavolts per meter. This defines the maximum achievable acceleration rate. If electric fields are generated in a certain environment, for example, by using the field of an electron beam, or the fields emerging as the result of charge separation in the plasma, then from a technical viewpoint, the acceleration rate can be increased almost indefinitely, up to the breakdown of the very vacuum, to the threshold of forming electron-positron pairs in vacuum. Accordingly, the first collective accelerators were developed right after the construction of the synchrophasotron. The member of the USSR Academy of Sciences, Vladimir Veksler, was sure that it would be the last large accelerator operating on the high-frequency electric field principle, that this direction would reach a dead end, and that only collective methods would be able to take charged particle energy to new heights. From the viewpoint of the development prospects of cyclic accelerators, Veksler was wrong. Solid proof of this, for instance, is the Large Hadron Collider, which accelerates particles up to an energy level of 7 trillion electron volts. And from the viewpoint of the development of collective acceleration methods, under Veksler's leadership, such work was initiated at our institute in the early 60s. Work on the creation of the so-called collective accelerator of heavy ions had carried on for more than 30 years. Its operating principle was supposed to be as follows. In an induction accelerator, an electron beam is being accelerated. Then this beam forms a fast spinning circle in the magnetic field. This circle is being pushed out of the magnetic field. The latter is loaded with heavy ions, and in the next induction accelerator, it is accelerated to the extent of sufficiently large energies. The speed of electrons is, in this case, equal to the speed of ions. Ions are inside the electron ring, and with respect to the mass, the ion energy is higher than the electron energy. The ratio of the heavy ion mass to the mass of an electron is several 100,000. That is why, at a short distance, at a short length of accelerator, it was possible to obtain a beam with an energy level greatly exceeding the energy of the synchrophasotron. This work was carried out under the guidance of a prominent Soviet scientist, namely Vladislav Sarantsev. In tribute to him, one of the regular accelerating seminars on charged particle accelerators is organized in Russia biannually. It is held once every 2 years, which started 1 year after the All-Russian Conference on Accelerators of Charged Particles. Our institute acts, traditionally, as the organizer of this event.